Hello there and welcome to lesson 13 in the series to learn programming in Scratch. Today you will use blocks to run a sprite on a line. The sprite should see or feel where the line is and then follow the line while it moves forward. The same principles are used in line following robots. The Otter hiking trail is officially the oldest in South Africa. The route is approximately 45 kilometers long and runs along the spectacular coastline between the Storms River mouth and Nature's Valley. While you walk on this trail, you have a breathtaking view of the sea, a chance to see dolphins playing in the waves, an opportunity to swim in a river, and even to explore the underwater world in tidal pools. You will walk in a dense forest, relax on a quiet beach, and explore flowers, insects, and bird life. The route was named after the southern Cape Otter, which occurs in the estuaries and streams of the South African coast. On the Otter Trail, you walk between 4 and 14 kilometers per day for 5 days. The Otter hiking trail may not be as demanding as a few other longer routes, such as the Amatola or Outeniqua, but it includes some cliffs to climb up and down with ropes, as well as technical river crossings. It is essential to be aware of the dates and the times of high and low tides when it comes to crossing the larger rivers like the Elandsbos River and the Bloukrans River. There are many streams and rivers where you can get drinking water, but hikers have to carry their gas cookers, sleeping bags, food and clothing. A small first aid bag, mountaineering rope, a route map and a thermal blanket is also necessary. There is no cell phone reception on the Otter route. A maximum of 12 hikers is allowed at a time. It is essential to plan long in advance because the route is popular and usually booked up for a year in advance. You can book at sand parks. Now answer the questions on this topic in your workbook. Today you will use blocks to code a line following sprite. The sprite should sense where the line is and then follow it. The principle to do this is to use two sensors on either side of the sprite that must stay on the line. To make these sensors, you put two small dots on the sprite. Use colors that are different from the rest of the sprite. Follow these instructions to modify the sprite costume. Let's use the bug sprite for this example. Click on Costumes, then add two small circles of different colors on the front edge of the sprite. Make the sprite 50% of its original size. Draw a line or circle for the path with the line thickness a little more than the distance between the two sensors. If I want to keep the bug on this line, both dots must stay on the line. When the right-hand side green dot goes off the line, the sprite must turn anti-clockwise. And when the left-hand side blue dot goes off the line, the sprite has to turn clockwise. Otherwise, the sprite has to go forward. The first new block you need is to test whether the colored dot on the sprite touches the line. This light blue block tests whether the first color on the sprite touches another color. If the colors touch, the block's condition is true. To select the colors, click on the color in the light blue block. Then click on the dropper at the bottom of the pop-up window. Then click the color of the dot on the sprite for the first color. Repeat the 3 steps for the second color in the light blue block to be the same as the line. You will need blocks to turn the sprite to follow the line. This blue block rotates the sprite the number of degrees clockwise relative to the direction in which the sprite is currently facing. This blue block turns the sprite the number of degrees clockwise relative to the direction in which the sprite is currently facing. To test if a condition is not true, for example if the color sensor does not touch the color of a line, you need the not block from the operators group. When you use this light green block, you can test whether the condition in the block is not true or false. For example, to turn if one of the dots is not on the root line. If the left-hand blue dot is no longer on the line, you must turn a little to the right. If the right-hand sensor, the light green dot, is no longer on the line, you must turn a little to the left. If you want to test if both dots are on the line, that is, if two conditions are true, you can combine two conditions as follows. This light green operator block combines two condition blocks. If both conditions are true, this block will be true. If only one of the two conditions is true, or both conditions are false, this block will be false. For example, here you test whether the blue dot is not touching the line and the light green dot is on the line. This light green block also combines two condition blocks. If one or both of the conditions are true, this block will be true. At least one of the conditions must be true. If both conditions are false, this block will also be false. For example, here you are testing whether at least one of the dots is on the line. To start your sprite facing in the right direction, the point in direction block can be used. You've used the motion block point towards to point the spaceship in the right direction before. But if the route twists and turns and the sprite should not look towards the finishing point, you can use the point in direction motion block to enter the degrees. This blue motion block allows the sprite to look in a specific direction. The easiest way to get the correct degrees is to turn the direction pointer under the stage to a set direction and then read the value of this direction and set it to make the sprite look in that direction. Finally, you should know when the sprite should stop. One way is to put a sprite at the end point of the route and then use the repeat until block to repeat until the sprite reaches the sprite at the finishing point. This light blue block tests whether a sprite is touching the other sprite. If so, the block's value is true. And if it does not touch the other sprite, the block's value is false. You need a loop to repeat an unknown number of times and stop when a condition is met. This orange block will run the blocks inside the C repeatedly as long as the light green condition block is false. If the condition does not change within the loop, it will execute infinitely. If the condition is true before the loop, the code within the repeat until block will be ignored, and the code after this block will be executed. For example, to stop when the bug reaches the tree, the go-to block places the bug in the starting position, and the point in direction block lets the sprite face the direction of the line. The repeat until loop lets the bug move until it reaches the tree. If the blue dot on the bug is not on the pink line, it turns a little to the right. And if the green dot isn't on the line, it turns the sprite a little to the left. The sprite then moves forward on the line. Now create a program in Scratch with the route of a hiking trail or any other line in the background. Save the program as hiking trail. Code the top view of a sprite to follow the route automatically when you click on the green flag. The sprite must turn when the road turns and stop at the endpoint. Save all the changes to the program. Here's an example of what your program might look like. Use the design cycle again. Ask questions, consider alternative solutions, plan your program, test the program repeatedly, and reflect on what you've learned afterwards. Write down any questions you have about the exercise in your workbook. Then discuss it with your friends or the teacher, or use the internet to find answers. Think about different solutions. For instance, you can draw the route in Scratch, or you can enter a map. Your route can be a winding road, a circle, or a straight line. There are also many possible sprites that you can use. You can use a sprite that looks like a person from the top, or one of the animals or vehicles in Scratch like Cat 2, or the beetle, or the ladybug. Draw the design for the background and the position of the sprites, and label the sprites in your workbook. Now write down the algorithm for your program. Follow your algorithm to write your program and check that your program meets the criteria against this rubric. Do you still remember that Eduardo de Bono wrote the book about the 6 thinking hats that help us reflect on what we've learned? Use this method again to reflect on the lesson. In the next lesson, you will write a program to simulate messages from ID chips in rhinos, and you will also learn about how to prevent rhino poaching. Until then, goodbye.